I have a very simple question for you before you go. If I put a number into a machine and the machine follows one rule, the question is, can you predict the output? Definitely, you can predict the output. For example, if the input is 2 and the rule is multiplied by 3, then you know that the output is what? Is 6. If the input is 5, the rule is multiplied by 3, I get 15. And obviously, if I give you 10 and I maintain the rule that we multiply by 3, you know that the output is 30. That is the basic idea of a function. One input goes through a rule and gives one output. So here I said this rule says every input, one output, right? And because that is one output, we call it a unique output. So every input produces a unique outcome or a unique output. In this example, I give you an illustration of a function, right? So a function is just a set of ordered pairs. You can see here it is represented as a set, right? This is a function because I have one input, which is 1, right? And the output is 3. The input is 2 here and the output is 5. So I can write this in this other presentation. So let me write 1, 2, and 3. Then I can write that. And this is what we call the domain. The set of inputs is the domain. And in the output here, we have 3 and 5 is repeating. So I won't write 5, 5. And this is what we call range or the codomain. So you can see that 1 maps to 3, right? 1 produces 3. Then 2 produces 5. And 3 produces 5. So it doesn't matter whether one input is matched to, different inputs are matched to different outputs, right? What matters is one input should only have one output. Let's look at this other example. So in the range I have the domain I have 1 and 2, domain. And in the range I have 3, 6, and 4. So this is the codomain or range, if you want to call it like that. So you can see that 1 produces 3, but at the same time, 1 produces 6, and 2 produces 4. Okay, but remember we said one input should only produce one output. In this case, 1 produces 3 and 6, and so this is not function, not a function at all. Okay, now in the same way, these functions can also be represented in a table, right? So this we normally call it a table of values. So you can see that every input here, every x value has one y values. -1 produces 2, 0 produces 2, and 1 produces 5. So it is a function. In the same way, this function can also be represented by a graph. So remember in the previous problem, we draw a table of values, and this table of values, we can put them on a graph and put the function. So this is how you know about if a graph represents a function. You use what we call a vertical line test. So if I draw a vertical line, right, a vertical line through the graph, it must only touch at one and only one point. So you can see that here it touches 1 at this point here. And if I draw through it on the right hand side, it touches 1 point. So A is a function. Okay. So what this means is that if I pick a value, for example, I pick a value right here, right? Let me use a different color. If I pick a value right here, this is a value of x, which is the input. You can see that it meets the graph right here. So this will be your input, right? This will be your input right here. This will be your maybe y1, and this is x1, okay? However, if I draw a line through the graph like that, and it touches the graph at two different points, it means that graph does not represent a function. It is just a relation. Okay, for example, here I put, let's say, x1, and this will be my y1, right? And this will be y2 on top. Okay, so in this case, x1, which is right here, is mapped to two values of y, this and that. And so this is not a function. In a nutshell, we said a function is just a relation that follows one rule. Every input produces one output.